The next question asks us to turn on the voltage connected to the deflection plates and to observe what happens when we power up those plates. Does anything change about the electron beam? So recall again, those deflection plates are angled slightly upward and downward on either side of the electron beam. Right now I've got barely anything. I've got 2 volts sending to those deflection plates, but as I increase the voltage here, notice that the beam angles down slightly, and at some point it disappears. I guess it's getting bent too much by that force that's on it. But if I turn the voltage back down, it returns to its normal orientation. And I'm going to go ahead and just switch the leads so that I switch which plate is positive and which plate is negative. If I do so, and then turn the voltage up, I notice that the beam is getting steered now in the upward direction, and again at some point disappears when I go too far out of the range there. So this is the basics of the technology they put in really old televisions back in the day. You send a beam of electrons towards the front of the screen, and by using electric fields and, as we'll see shortly, magnetic fields, you can steer that electron beam so that it hits a precise location on the screen and lights up a certain phosphor, either producing just a light spot on the early black and white televisions or a certain color on later color televisions. So this is the end of part 1 of this particular experiment.